Thank you so much for joining our live lesson tonight. We're going to discuss Mathematics Paper 1, Section 1, a very serious paper actually, and it's my hope that you guys are going to benefit from this particular program, Shifting Grades Online School. If you have not subscribed, kindly ensure to subscribe. You can also share this link so that you may invite a friend. As we wait for our friends to join us, let me bring to your attention our holiday program here, whereby we're going to have very powerful lessons on Google Meet. You are invited to enroll. The registration fee is very little amount, some little amount that we expect anyone to afford. So please reach out through the number which is attached here, 0704 15 33 66. When you get in touch with us, you are going to enroll and you shall really benefit from this. We can get started. I can see we are a good number. So let's get to number 1 of this serious paper. Evaluate without a mathematical table or a calculator the square root of negative 26 minus negative 17 divided by negative 3, then minus negative 24 minus negative 2 multiplied by 6 divided by 2. So as you can see, this question has the part on the right hand side, then a minus, another part on the left, then we have the square root sign. So we are going to do 3 parts and we finish up by taking the square root. Solution to this question. Let me begin by this left hand side. This part first. We just deal with that. The paper has very technical question. This is just a beginning. You will see as we continue. So negative 26. When we talk about minus a negative, we should open that bracket by multiplying a negative and a negative. So the sign changes to a positive. 17 out of negative 3. Then now we can talk about negative 26 plus 17, which is a negative 9. Then out of negative 3. When you divide a negative and a negative, the sign changes to positive, and now we are getting a 3 from that side. Then there is another part. Before we subtract, let's also do the other part independently. Then we will be combining the two. We shall be combining the two later. Let's do this other part now. Negative 24 minus negative 2 multiplied by 6 becomes negative 12. That way, everything divided by 2. So this is negative 24 plus negative 24 plus 12. Then because of negative following a negative, or rather a negative opening the bracket here, we are multiplying a negative and a negative to become positive 12, then over 2. So this shall be negative 12 out of 2, giving us a negative 6. So we are done with the right hand side. Now we need to combine what we got on the left hand side, 3, minus what we are getting, a negative 6. That way. So this is 3 plus 6, giving us 9. But now remember, we were to take square root now for us to be the final answer. We are supposed to take square root. So now you obtain the square root of 9, which without a calculator or a math table should be done using factorization. So taking square root using factorization, we are supposed to factorize 9. The closest prime factor here, because 9 is not even, should be 3. So by 3, we get 3. 9 is fully factorized. So 9 is equivalent to 3 times 3. So from the two common factors, we pick only one. So the final answer now becomes 3, which is the square root of 9. The square root of 9. Remember to comment to this live lesson. Remember to share, to invite a friend. Remember to subscribe. This is a very powerful presentation. Please ensure that you invite a friend. Don't just benefit alone. I know the lessons are really beneficial, and it's not good for us to forget our friends who we even come from the same school, same markets, same villages. Let's just invite them. Let's just invite them. Please comment. Let's know where you're watching us from. Asumbi Girls, that one is in Nyanza. Thank you. Our Lady of Mercy, South B, thank you. Garissa, thank you. Sakawe from Sunlight, thank you. Thank you, thank you. Francis, St. Francis, thank you. Boni Girls, thank you so much. Stephanie Kenya High, thank you. Stephanie Butere Girls. Wow, Frida from Butere Girls, thank you. Those are champions of soccer. Let's remember that our consultation line is 07 04 15 33 66. So you can reach out through that number and you will get to know more about our programs. Let's look at number 2, ladies and gentlemen. Number 2 says that the interior angle of a regular polygon is 20 more than 3 times its exterior angle. Calculate the number of sides of the polygon and name it. 2 instructions. Thank you, Makweni boys. Thank you, Elders boys. Thank you, Mandera Secondary. Sumbukia, thank you so much. Let's look at how to approach this one. We are already told that the interior angle is 20 more than 3 times the exterior. So we can let the exterior angle be x. If it is x, then the interior, because we are already given the relation, we are told that the interior is 20 more than 3 times the exterior. So when we take 3 times the exterior, we add 20. That's how great the interior is. Something that we should know about interior angle and exterior angle of a polygon, whether regular or irregular, is that interior angle plus exterior angle usually give 180. So x plus 3x plus 20, this should give us 180. So that we have 4x plus 20. It can be taken to the right hand side, whereby the 20 is subtracted to give us 160. When we divide it through by 4, we shall get 40 degrees. So the value of the exterior angle is 40 degrees. If the value of the exterior angle is 40, ladies and gentlemen, we can now talk about what? We can now talk about the number of sides being given by 360 out of the size of an exterior angle. So the number of sides shall be 360 out of 40, giving us 9. So this polygon is having 9 sides, and definitely the name shall be nonagon. So the name is nonagon. The sides are 9. Let's ensure that we remain. In this platform. Thank you, Bonnie girls. Yeah, thank you for being around, ladies and gentlemen. We can now proceed to the next question. But as we proceed to the next question, if I may ask a question, how have you been purchasing airtime for your lines? You know that we have the best platform here, whereby you can just purchase airtime for any network, Safaricom, Airtel, Telcom. You just go to your M-Pesa menu, Lipa na M-Pesa. Instead of going for scratch cards, go to your Lipa na M-Pesa, the pay bill option, 73 73 56. a very good number which can be memorized by anyone. Remember to share it even with your friends. Then the account is your own phone number, the phone number that you now want to purchase airtime for. You enter it. After that, you proceed to enter the amount that you'd like to spend. Then after that, now you can proceed, purchase airtime, and you will get your airtime instantly. So you will try this one later. Just write the pay bill 73.56. Let's proceed now. The marked price of a TV set was 50,000 Kenya shillings. John sold it to Wambui at a discount of 6%. By doing so, he made a profit of 20% and he earned a commission of 22.5% on the profit. Determine the commission he earned. This is not a simple question. It's a question that requires a student to know what they are exactly doing. So we are told that the marked price was 50,000 Kenya shillings for this particular TV set. Then John is selling it to Wambui at a discount of 6. That means Wambui did not buy it at 50,000 because she was given a discount of 6%. Then she bought it at 94%. So 94% of 50,000. This will give us the selling price, the amount Wambui bought it. And this is exactly 47,000. 47,000 that way. So this is the amount that Wambui bought. Now, you're supposed to know something. After this, John still made a profit of 20%. Therefore, we can say if there is a profit of 20%, then the amount of 47,000 is together with the profit. So 120%. The percentage represented by this amount now on the other side is 47, is a 120%. 120%. Because there is a profit of 20%. So through this, we can determine the amount that John had bought this particular TV set. So what is 100%? The amount that John bought the dress. And this is going to exactly be, we take 47,000, we multiply by 100, then we divide by 120. So this is going to give us Kenya shillings 39,166.66 recurring. So we can have a 70 actually at that point. So this is the amount that John and bought this particular TV set. That is why after selling at 47,000, there was a profit of 20%. So we can now calculate the profit itself. What is the profit? Remember, we could have even gone direct to calculate the profit by obtaining 20%. Therefore, the profit shall be 47,000 minus the amount he used to acquire the dress. So this is going to be Kenya shillings 7833.33. Yeah, this is the amount in Kenya shillings that now John had used to, received as the profit. Now, this gentleman has been employed somewhere by the owner of this particular electronics shop. Therefore, it means that he is not going to pocket the profit. He shall just be given 22.5% of this. So this is what John is going to receive. 22.5% of 7833.33. So Kenya shillings, the commission now, because the commission is part of the profit, 1762.50. 1762.50. Thank you from Muranga, watching from Kiambu. Thank you, thank you. Makunga School, Kitale, thank you. Garissa High, thank you. Gituru Boys, thank you. Turkana County, thank you. Garissa High, thank you. Makueni Boys, thank you. Gatito Sek, thank you. Boni Girls, Collins from Kisumu, thank you so much. We proceed to the next question, which is the number 4. A very good question in number 4. Let's look at this, ladies and gentlemen. Let's follow up with this. Remember, the enrollment fee for our serious program is only 2,500. Once you pay 2,500 through our M-Pesa line 0704 153366, you are going to get access to very serious examiners in the country who are going to take you through physics, chemistry, biology, mathematics, Kiswahili, and English. Very serious program. So please don't be left out. Some people may fail to enroll thinking that the charges are too high, but for 2 weeks, 6 subjects, and it is going to run from 8:30 a.m. all the way to 2 p.m. in the day. It's a very considerate amount. So please reach out, make the payment, and catch the best from the best, of course. We are told in this question number 4 to calculate the angle ACX in radians. The instructions there are 2: calculating the angle ACX and in radians. So ACX is going to be this particular angle, and we are going to find it in radians. So let's look at this. The length given is AC, AB, and BC. So we can say that the name of this length is usually named using the angle opposite to it. So this is length small letter b. Now the length 4 will be named using small letter a, and the length of 9 centimeters using small letter c. That way, we name the lengths according to trigonometry 2 using the opposite angles. If we name them that way, now we can proceed to find the value of these angles using what we call the cosine rule. So the cosine rule states this: if we need the angle at C, for example, then the length C squared is the same as when we take B squared plus A squared minus 2 multiplied by B and A, the cosine of the angle at C. The cosine of the angle at C. Because I'm interested in the angle at C. Therefore, the length C is 9 squared equals to B squared, which is 7, plus A squared, which is 4, minus 2 multiplied by 7 multiplied by 4, the cosine of the angle at C. That way. So now we can try to work out a few things here. This is 81 equals to, I take 49 plus 16, giving us 65, minus 2 multiplied by 7 and 4. This gives us 56. The cosine of the angle at C. So I have to take now 81. I subtract 65. This gives me 16 equals to negative 56, the cosine of C. That way. So how do I get the cosine of C? To remain with the cosine of C, I'm supposed to take 16 divided by negative 56. And this gives me negative 0.2. Look at this. 0.2857. I want us to be together up to that point first. Moi School, thank you so much. Kabarak and Moi School Nakuru, thank you. Let's look at this. We are having an angle which is having a negative cosine. This is to mean that the angle is not acute first. This angle is not in the first quadrant. It's not an acute angle. It is in the second quadrant. Therefore, we need to get the sine inverse, cosine inverse of this value. And this is giving us 106.6. So C equals to the cos inverse of 0. There is a negative there. Be very careful. Negative 0.2857. And this gives us the value of the angle at C as 106.60 degrees. But now we didn't want the angle inside. We needed the angle ACX, which is the outer angle. So we take 180 and we subtract 106.6. What are we going to get from this point? Watching from Machakos, thank you so much. Tiguigas, thank you. St. Joseph's Kibwezi, thank you. Oletipis Narok, thank you. Moi Secondary Nakuru, thank you. 180 minus this value, I'll get 73.40 degrees. 73.40 degrees. Then now we are supposed to get back to the instructions and convert this to radians. We are supposed to know that 2 pi radians equals to 360 degrees. In other words, to get pi radian, one radian, in other words, we need to divide through by 2 pi. So 180 divided by 360 divided by 2 pi becomes 180 over pi, that way. And we will now say this, that if 180 over pi degrees equals to 1 radian, what about 73.40? It shall be 73.40 times 1 out of, divided by 180 over pi. So this is going to give us, we multiply by pi out of 180. This gives us 1.281. 1.281 radians. Not degrees now, radians. Yeah, radians. Thank you from Goto Boys. That is Zawadi. Thank you so much for being in the platform. Let's look at number 5. This is a question for the Form 2s. This one is for the Form 2s, a paper 1 question, which is required by everybody following us. Whether you are in Form 2, Form 3, Form 4, you really need this one. The masses of two similar conical artifacts are 2,000 and 250 respectively. The radius of the smaller is 15. Calculate the radius of the bigger artifacts. Okay, one thing you're supposed to know is that all the measurements which are in one dimension gives us linear scale factor. Listen to this one carefully. Linear scale factor is given by one-dimensional measurements. These include length, width, radius, height, all measurements which are linear, in other words. Then area scale factor is given by two-dimensional measurements. Two-dimensional measurements. These include area, base area, surface area, curved surface area, anywhere where area is mentioned. Anywhere you hear the mentioning of area, Just know that we are talking about area scale factor. Then there is volume scale factor. This one is for three-dimensional measurements, and they include the volume itself. For you to get volume scale factor, you're supposed to relate three-dimensional measurements: volume, mass, density, capacity. So capacity, density, mass, and volume are measurements in 3 dimensions. They are not linear measurements, and they are not 2-dimensional measurements. And in this case, as we handle number 5 now, I want you to know that the masses will give us volume scale factor. So volume scale factor equals to 2000 out of 250. This can simplify to 8 out of 1 if I have to give it as a fraction. 8 out of 1, meaning that volume of the bigger artifacts out of the smaller one is 8 over 1. In other words, the ratio of all 3-dimensional measurements for the 2 conical artifacts should give us 8 over 1. And from this, we can now talk about linear scale factor, whereby we need to obtain the third root, or rather the cube root of the volume scale factor. This is 2 out of 1. If we have the linear scale factor, then now we can relate. We can now relate the radii. Radius is a linear measurement, and so it gives us a linear scale factor. Now, for the smaller, radius of the smaller is 15. So for the bigger, should be 15 multiplied by 2 out of 1. This is exactly 30 centimeters. 30 centimeters. If we had been given the radius of the smaller, okay, if we had been given the radius of the bigger for us to get that of the smaller, then we would have multiplied by this ratio, but in a way that it would decrease the value. Look at the second one. The area, find or calculate the area of the larger if the area of the smaller one is 108. We have now to go to what we call area scale factor, because in this case now we are relating areas. Therefore, area scale factor is given by linear scale factor squared. This is 4 over 1. 4 out of 1. Now with this, we are already given the area of the smaller. We need that one of the larger. So we need to take 108 multiplied by 4 out of 1. When we carry out this multiplication, ladies and gentlemen, let me just confirm it. When we carry out this multiplication, 108 by 4, we are getting 432. Yeah, 432. 432 square centimeters. 432 square centimeters. Look at a very interesting question in number 6. I hope you are getting me clear. St. Francis Mangu, thank you so much. Thank you, thank you. Kimilili Boys, thank you. Busia, thank you. Nyabisase in Kisii, thank you. Thank you, thank you. Murray, thank you so much. Thank you, thank you, thank you. So let's now check this interesting question here. And remember to subscribe. Ole Kajuado, thank you so much. Thank you, thank you, thank you. Number 6 is a very interesting question. That's where we are now. A triangle T with vertices A, 2, 4, B, 6, 2, and C, 4, 8 is mapped on triangle T prime with vertices A prime, 10, 0, B prime, 8, -4, C prime, 14, -2 by a rotation. The examiner has specified that it is by a rotation. Part A. On the grid provided below, draw triangle T and its image T prime. Just plotting two triangles. Imagine you get 2 marks. Is this not free marks? Are these marks not free? Anyway, let's check. How do we ensure that we have plotted the two independently? So let me start by plotting T. 2, 4. The examiner has already given us the axis very well indicated, well labeled. So 2, 4, 6, 2. 2, 4, this one. 6, 2, this point. Is it 6, 2? Yeah. Then 4, 8. 4, 8. This is C. This is A. This is B. That is the first triangle. We can connect the dots now to have it. This is the first triangle. Triangle T. And you'll find somebody following us daily, then their friends don't know about shifting grades. That is not fair. You are not a good friend to them. Please explain to them about the goodies of being around, about the advantages of following shifting grades. Is mapped onto triangle T prime with vertices T0, 10, 0. So 10, 0 is exactly lying here. This is our A prime. Then what else do we have? 8, -4. 8, -4, it's here. That's our B prime. Then 14, -2. 14, -2. This is where C prime is. We can now connect them to have the image. Remember, this is T. Now we want to connect to have T prime. T prime. This is now, we are now having the two triangles. Remember now, there is a part B. This one is T prime. We label it that way inside. Now, remember, we are having a part B which says what? Determine the center and angle of rotation that maps T onto T prime. How can we describe the rotation which was involved in this particular transformation? So we are supposed to connect a point together with its image. That is the first thing you're supposed to do. Let that one be known. We connect, for example, we can connect B and B prime. You connect B and B prime. So let me do that. And I hope my labeling is right here. B and B prime. After connecting B and B prime, we are supposed now to bisect. We bisect this one perpendicularly. B prime, we bisect it. You just connect, then bisect. Then we bisect. So let me bisect this. I've bisected. I don't know whether my bisection is very perfect. Let me redo it. Just want to bisect B prime, then I bisect perpendicularly. That way. B prime, then we bisect it perpendicularly. That one is done. We can do another coordinate like C prime or A prime. Let me do it for A prime. So you connect A to A prime and you also bisect A prime, then we bisect. Let's check that. A prime connected. Then we also bisect A prime, then we bisect. A has been connected to A prime, then bisected. Now, when you look at the bisectors, you shall discover that if this is bisector 1, then this is bisector 2. You discover that they are meeting somewhere. They are meeting somewhere. Wherever the two bisectors meet, that is our center for the rotation. So, to describe a rotation, we need to mention the center of the rotation. And here, we are having center 4, -2. You just read the coordinates. 4, -2. This is the point. Then now we are supposed to identify the angle of rotation. And remember, it should be the angle together with the direction. If it's 90, you tell us, is it positive 90 or negative 90? So how do we determine the angle of rotation now? We are supposed, again, to work with coordinates. I choose coordinate A and its image. So I'm supposed to connect A to the center, then again to A prime. A to the center, then to A prime. So I connect A to the center of the rotation that way. Then again, I link from the center now to where the image is that way. We connect A to the center, then again to the image. Then now we check the angle together with the direction of turning. So the angle here is 90 degrees. And how are we turning? From A to A prime, we are turning through the clockwise direction. We are turning in the clockwise direction through an angle of 90. Therefore, we will say that this is -90 degrees. -90 degrees. That means 90 in the clockwise direction. 90 in the clockwise direction. So that's how we are supposed to determine the center and also the angle of rotation. If we found that we were moving in the other direction, we would have said it is positive. We would have said it is positive. Yeah, thank you. Thank you for following, guys. I can see. I can see. Thank you, Ryan from Kabiaga. Thank you, Kiambu. Thank you. Kabianga, I can see you. And thank you so much. We now proceed to number 7. These questions are very serious. Please give them the seriousness that they deserve. Kindly let us give the program the seriousness that it deserves. Number 7. Solve the pair of simultaneous equations. 2x minus y equals to 3. Then x squared minus xy equals to -4. This is I want you to know that this is a quadratic equation and also simultaneous. Therefore, the knowledge on simultaneous should be embraced. The knowledge on quadratic should also be embraced. So let us see how we can solve the two. If we are solving simultaneously, we cannot manage to solve using the elimination method. We cannot manage to use what we call the matrix method. We are only supposed to use the substitution method. So for us to solve using substitution method, we are supposed to express one of the unknowns from one of the equations in terms of the other. Therefore, I will choose to express y from equation 1. So from equation 1, which says 2x minus y equals to 3, we can choose to bring y to the right-hand side such that it is positive. Then 3 goes to the left such that it is also negative. It becomes now negative. So 2x minus 3. So from equation 1, from equation 1, the value of y can be expressed as 2x minus 3. And that means we can substitute it in equation 2. So I'm now going to rewrite equation 2. Observe this one keenly. I'm rewriting equation 2, but now instead of y, I will substitute it with 2x minus 3. Therefore, equation 2 becomes x squared minus x instead of y, 2x minus 3. Then this is equal to negative 4. X squared minus 2x squared. Then positive 3x equals to negative 4. You see? So this is now becoming a quadratic equation. When you substitute or when you group terms, this shall be negative x squared. Yeah, negative x because of x squared minus 2x. So negative x plus 3x equals to negative 4. We now supposed to arrange the equation so that it may take the format of quadratic equations. Allow me bring the negative to the right, whereby it becomes x squared. Then the 3x also to the right, where it becomes negative. And we are already having negative 4 on that side, that way. I hope you have observed that arrangement of terms very keenly. Negative x squared has gone to the right to become positive, 3x to the right to become negative, and now we are already having negative 4 already on that side. So now we remain with a 0 on one side. A 0 remains on one side. Let people be focused, please. Unnecessary chat is not important. Just tell us where you come from. Let's know your school, please. Kindly identify with your school. Actually, identify with your math teacher, please. Let the lesson be very interactive. Identify with your math teacher. Let's know whether you are getting what we are learning from this forum. Remember to subscribe. Remember to share. Remember to invite a friend. Remember to be here tomorrow. Yeah. Okay. Now we are having a quadratic equation that has to be solved. Because of the form 2's around, allow me solve it using what we call factorization method, whereby I need a product of a times c. We are having 1 and negative 4 as our values of a and c. So that's negative 4. And sum, which is equal to value at b, which is a negative 3. We want two factors such that their product is negative 4 and their sum negative 3. And this is negative 4 and positive 1. Negative 4 and positive 1 multiplied gives us negative 4, added gives us negative 3. So at this point now, we can replace negative 3 with negative 4 and 1. So the equation becomes x squared minus 4x plus x minus 4 equals to 0. From the first two, we factor out x to remain with x minus 4. Then in the other two, we factor out only 1 to remain with x minus 4. This is equal to 0. So from the inside of the brackets, we have x minus 4. From outside the brackets, we have x and a positive 1 equals to 0. At this particular point now, ladies and gentlemen, we can now say either x minus 4 equals to 0 or x plus 1 equals to 0. So from the first one, x equals to 4 or x equals to negative 1. So we have the values of x. We have the two values of x. How shall we get the values of y? Remember, there is an expression for y. when we were substituting, we said that y equals to 2x minus 3. So when the value of x equals to 4, the value of y shall be, when x equals to 4, the value of y shall be, we substitute 4. 2 by 4 becomes 8. Minus 3, we get 5. Then, when the value of x equals to negative 1, what shall be the value of y? The value of y shall be 2 multiplied by negative 1, we get negative 2. Then minus 3, we get negative 5. So there are 2 values of x and 2 values of y. When x is 4, there is a corresponding value of y, which is 5. When x equals to negative 1, there is a corresponding value of y, which is negative 5. Thank you for being around. Thank you. Kangumo High, thank you, Kagumo High. Moiphoses Nairobi, thank you so much. Thank you. Somebody's asking about whether it's all the subjects or... That's a good question. Jeremy from Lenana School, thank you so much. Thank you from Lenana School. Say hi to Madam Bet, your HOD Mathematics, Lenana School. Madam Yeshia, thank you. All right. Cabo Boys, thank you. Let's continue now. There is a very interesting question here in number 8. In this one now, I'm begging for your attention. Now. Let's focus on number 8, ladies and gentlemen. Malka Mariboys, thank you. Loreto Rimoro, wow, thank you so much. I know some of your teachers, Kina Mr. Obuong, Mr. Otieno Physics, among other teachers. All right, Kilifi Township, our program is still being reminded. You are being reminded of our program here. You are reminded of our program. Kindly enroll. Reach out through my number 0704153366. It is already on the poster. The number is already on the poster. You can see it here. Just reach out for more information. It shall be very interactive. Muranga High, thank you for turning up. Number 8. I hope you are now ready for this. I hope you are just ready for this. 2 of the vertices of a triangle, A, 1, 5, and B, 3, 1. The images of A and B are 2, 10, and 6, 2, respectively. Calculate the center and scale factor of enlargement. So when a particular triangle has been enlarged, the coordinates of A, 1, 5, become 2, 10. The coordinates of B, which is 3, 1, become 6, 2. Then we are to find the center. And the scale factor of the enlargement. Let us see how to go about this one. There are very many concepts that we can apply for us to arrive at the center and the scale factor. But allow me apply a very interesting concept here. Assuming that we have a center somewhere. We don't know where the center is. But we know that we can connect A to A prime, A to A prime using a straight line. Let me bring A prime somewhere here. I'm trying to sketch this information. A to A prime can be somewhere there. Yeah. A to A prime. Remember A is 1, 5. A prime is 2, 10. 2, 10. A to A prime, 2, 10. Then now, we are having a B and B prime. One thing we are sure about AA prime and BB prime is that they meet at the center of the, Wherever they meet is the center. So we can have B, which is a 3, 1, and B prime, which is coordinate 6, 2. Yeah, coordinate 6, 2. Now, according to the knowledge that we have, Mount Kinagop, I notice your presence. According to the knowledge that we have about straight lines, we all know that we can find the point where straight lines are meeting by solving the lines simultaneously. So we can get the line AA prime. Line AA prime, we can get its gradient. We take the change in y, 10 minus 5, out of the change in x, 2 minus 1. So this is going to be 5. This first line is having a gradient of 5. So we can express the gradient of 5 by taking change in y, y minus 5, change in x, x minus 1. A cross multiplication will give us y minus 5 equals to 5x minus 5. So y equals to 5x. Yeah, y equals to 5x. That's simple. Y equals to 5x. This can be equation 1. Then the other equation is a BB prime. The gradient shall be 2 minus 1 out of 6 minus 3. So I'm getting 1 over 3. A third is the gradient. This gradient can now be expressed. A third equals to change in y, y minus 2 out of change in x, x minus 6. Yeah, x minus 6. So now we can cross multiply to have 3y minus 6 equals to x minus 6. If we arrange these terms, you discover that we are having 3y equals to x. 3y equals to x. 3y equals to x. If 3y equals to x, then it means that y equals to a third x. Yeah, y equals to a third x. If y equals to a third x, now we can solve the two equations. We can solve the two equations. We can solve the two equations to get their point of intersection. Their point of intersection. This is equation 2. Equation 2. So in equation 1, we can say that the value of x, this is also equation 2. Equation 1, y equals to 5x. Equation 2, x equals to 3y. So now we can solve for the value of x by saying that y equals to, instead of x, we write 5, 3y. So you discover that from this, the value of y is only 0 because we are having y's on both sides. Then again, when we substitute in this one, you shall still discover that the value of x is also 0 because we will be having x on both sides. So the value of x is 0, the value of y is 0, meaning that the center of the rotation is 0, 0. If we have the center of rotation as 0, 0, not rotation but enlargement, we can now find the center of enlargement is 0. So now we can find the scale factor by saying the vector from the center to A prime has been multiplied. So from the center to A, there should be a certain factor multiplying to give us from center to A prime. So we will say this constant times the first vector 1, 5 should give us the second vector, which is 2, 10. So when you consider the x component, k is equal to 2. And also, when you consider the y component, 5k equals to 10. 5k equals to 10. That confirms that k equals to 2. We can even consider the other line B, B prime. From the center to B, we can say that from the center to B, that vector should be multiplied by a certain factor to give us from center to B prime. So k from center, which is 0, 0 to B, it's vector 3, 1. And from center to B prime, 6, 2. So from this, we can also observe that k multiplied by 3, that is 3k equals to 6, confirming that k is 2. From the y component, k is directly equal to 2. So from this, we can make a conclusion that the scale factor for this particular enlargement is just 2. The scale factor of this particular enlargement is equal to 2. Scale factor equals to 2. Number 9 now. Number 9. Solve for x in 16 power x plus 4 power 2x minus 1 equals to 80. Look at this equation in number 9. We are supposed to say that all these composite numbers can be put into the least common base possible. Therefore, 16 can be expressed as 2 power 4, and there is already a power x there, don't forget, plus 4 can be written as 2 power 2, and there is already an existing power of 2x minus 1 equals to 80. 80 cannot be put to base 2. 80 cannot be put to base 2 that way. So this is 2 power 4x plus 2 power 4x minus 2 equals to 80. Equals to 80. That is where now we are. That is where we stand. At that point, ladies and gentlemen, we can now say that according to the laws of indices, there is one that says when we have a power m divided by a power n, you see the base is the same. We solve this one by taking just the base and we subtract the powers. This is the second law of indices. The second law of indices. Thank you. I know you are following up. This is what I want us to. I can see somebody from Zambia following. Thank you so much. Bishop Mazoldi. Thank you. Sirinda Mixed School. Thank you. Thank you. So let's continue watching this. Look, this is the law of indices, and I want us to apply it. Now, applying this means that in the second term, we shall say, because we are already having the powers subtracted, it means something was divided by another one. So 2 power 4x plus 2 power 4x divided by 2 power 2. That's why we are having one base and the powers subtracted equals to 80. I hope we are together in this interpretation of the law. I hope we are together in that interpretation. I know you're used in interpreting it in the forward side. Now we are applying it the other way around. We are applying it the other way around. Remember, 2 power 2 is 4. So now that 2 power 4x is appearing in most cases, we can let 2 power 4x to be a certain unknown, say even t. Now, if we let it to be t, then we say, instead of 2 power 4x, t plus t out of 4 equals to 80. T out of 4 is a quarter t. So 1 1/4 or 1.25 t equals to 80. And from here now we can say the value of t equals to, let me divide 80 out of 1.25. Ladies and gentlemen, I'm getting 64. When I get 64 now, I say, what were we trying to solve as our t? It is 2 power 4x. Therefore, we will say, now 2 power 4x equals to 64. And you see now, 2 power 4x equals to 2 power 6. Because now 64 can be put under base 2. So with this now, because the base is already the same, now we can say 4x equals to 6. And therefore, the value of x equals to 6 over 4, which is 3 over 2. But your final answer should now be 1.5, which can also be written as 1.5. You can't leave your answer as 3 over 2. That one, you'll be penalized. You can't leave your answer as 3 over 2. As a mature student mathematically, your answers are supposed to be simplified. Look at number 10. Without using a calculator or a mathematical table, evaluate. What are we evaluating? The cosine squared of 30 minus the tan of 45 divided by 2 multiplied by the sine of 30 degrees plus the tan of 60 squared. These are trigonometric ratios of special angles. And I want to tell you for free, this one will even appear in paper 2 in the topic of SADS. You'll be told express as SADS and rationalize. Amazing Grace, thank you. Kisi Bonventure, thank you. Ringer Boys, thank you so much. Yeah, so this one will still appear even in paper 2. That's why you are supposed to know how to work out trigonometric ratios of special angles, which can be given as fractions or as surds. As fractions or as surds. So let's look at this. We are supposed to know, first of all, that, I'm still copying the link to share with friends, and I hope you are still doing the same. So we are going to ensure that I show you how to solve this. So we are going to assume I want to deal with 60 and 30, then 45 later. So we assume an equilateral triangle, which is having 2 units. An equilateral triangle with 2 units. Let's look at this. If it is equilateral, this is 60. This is also 60. And up there, it is also 60. Then 2 units, 2 units, 2 units. So this equilateral triangle is supposed to be bisected. When you bisect like that, the angle here becomes 30. And if it has become 30 and the angle at the base becomes right angled, we can find the height. Let's find the height here. The vertical height should be a Pythagoras theorem, 2 squared minus, after bisecting, this becomes 1 and this also becomes 1. It was 2, so we split it into 1 and 1. 1 squared, then the square root to get the vertical height using Pythagoras theorem. So this should become now the square root of 3. So we leave it as a surd. The height there is the square root of 3. If it is the square root of 3, then we can express trigonometric ratios of 30 and 60 by saying that we need cos 60, cos 30, that is. The cosine of 30 is going to be, 30 is up there. So we need the adjacent length out of hypotenuse. The adjacent is √3 out of hypotenuse 2. That one is done. We also need, I can see the sine of 30. We need the sine of 30. 30 is up there. So for us to get the sine of 30, we need the opposite length, which is 1, out of hypotenuse, which is 2. Then we also need the tangent of 60. The tangent of 60. We can use the 60 at the base here. Tangent is given by opposite out of adjacent. The opposite length is √3 over 1. So it remains √3. So we have expressed the three trigonometric ratios according to what has been provided here. The next thing we're supposed to know about tan 45 is usually 1. The tan of 45 is usually 1. So if tan 45 is 1, now we can substitute everything. Let's now substitute cosine of 30 squared. So the root of 3 over 2 squared. Then minus the tan of 45, which is 1, out of 2 multiplied by the sine of 30, which is half. Then plus the tan of 60 squared. So √3 squared. The tan of 60 squared. √3 squared. Let's begin squaring. √3 over 2 squared means, you know, √3 squared becomes 3 and 2 squared becomes 4. Then minus 1. Out of here, we just get 1 plus. The root of 3 squared becomes 3. So we are already having the denominator as 4. That way, 1 plus 3. Then when we take 3/4 minus 1, we get negative a quarter. So negative a quarter divided by 4. Negative a quarter divided by 4 means multiplying by a quarter. Dividing by 4 means multiplying by a quarter. I hope you understand that concept of dividing fractions. To divide by 4 means to multiply by a quarter. So negative 1 out of 16 now becomes the final answer. Negative 1 out of 16 becomes our final answer. So that's how we're supposed to work out a question like number 10. Remember our consultation line, 0704 15 33 66. Yeah, that's our consultation line. You can reach out for our programs. Please reach out. Let's know how we can help you. Yeah. And we are sustaining a good number up to this point. We are now in number 11. Now in number 11. The figure below is a prism, triangular prism for that case. Uniform cross-section in which AF is equal to FB 3 centimeters. AF and FB are equal to 3 centimeters. Then AB equals to 4 centimeters. AB 4 centimeters. Then the length BC is 5 centimeters. Clearly draw a well-labeled net of this particular prism. The drawing of nets, ladies and gentlemen. The drawing of nets. Form 1 work, yet very serious. For you to draw a net, you are supposed to, first of all, understand that these solids are in 3 dimensions. Therefore, you should open up a solid in its net such that in case you fold back the net, you can get the solid that you are representing. Therefore, a net should be showing all the faces plainly now, because some of the faces are hidden in 3 dimensions. Now you expose all of them on a plane. So we are going to expose all the surfaces. And how many are they? We can see the base, which is 1. Then there are triangular faces, whereby we can have this one as the second one and this one 3. Those are 3. Then we have some other triangular, rectangular faces now. You know the base is rectangular. The base we are calling 1. It's rectangular. But now there are other slanting rectangles. So this can be the 4th one, and the 5th one is here. So we are having 5 faces. A triangular base, some other sloping triangles, then the front triangle and the far triangle. Then now, watching from Nanyuki, wow, Jojo girls, thank you so much. Thank you for being around. I may not see all the comments because I'm serious with the presentation. Understand that I recognize everybody. Just ensure that in the next, where can I get this paper? I'm posting my number every now and then so that you may WhatsApp me. Please make sure you get the papers. They are free of charge. Just get the papers. We will share in WhatsApp. Mr. Josephat Mureithi, thank you so much. Josephat, thank you, Mwalimu. Okay, let's see. Let's see how we can open up this net now. It is a solid, we want to make it a net. So we begin with the base. We begin with the base, which is 5 by 4, and it is rectangular. 5 by 4. Let's draw the rectangular base. 5 by 4. 5 centimeters, and you ensure that you measure 5 by 4. The base 5 by 4 centimeters. What is the name of the base? A, B, C, D. A, B, C, D. I've drawn the base already. That is the base. Then, now attached to this base, we have 2 other rectangles, whereby we can have a B, C, E, F. And because this one is 3, and this one also 3, we can now draw the 3 centimeters to get F and E. To get F and E. Remember, these are 4 centimeters. These are 5 centimeters. So now we need 3 centimeters. 3 centimeters here. And also the other rectangle, which was on the opposite side. 3 centimeters. 3 centimeters. So let me draw that. So this is 3 centimeters by 3 centimeters. The 5 is extended to this point. This is also 3 centimeters. The 5 is extended to this side automatically. Now we are talking about one face being FE. So this is FE. And also the rectangle on the other side is also FE. Because if we fold them, they are supposed to meet to form this FE. The 2 rectangles are supposed to be folded such that we get our FE once again. Then now, connected to AB is a triangle, and also connected to DC is also a triangle. Therefore, I'm going to stand at A using 3 centimeters. I make an arc, and standing at B, I cut that arc. Then I also stand at D, I make an arc, and at C, I cut that arc. Then now I'll be able to draw triangles very conveniently. This way, I connect P to B. That way. Then I also connect this one to B. And also the other side to D that way. Now, when I have drawn that, when I have drawn that now, I will be able to say that I'll be able to say that this one is E and this one is F. Yeah, well labeled. The labeling is equally very important. Yeah, so now these are 3 centimeters. 3 centimeters, you see? 3 centimeters, 3 centimeters. Now, assuming that I was to fold this particular net, assuming that, thank you, Victor Otieno. How many questions do we have? Section 1, 16 questions. Tomorrow we'll be doing section 2. All right. Assuming that I fold my net now, I'll be able to make this particular solid. So whenever you open up a net, be sure that you can close it up to form the solid that you are trying to represent. Yeah, because a net represents a particular solid. Now we go to number 12, ladies and gentlemen. A very simple question. A very simple question on area approximation. This is a question that I want us to do again with a lot of keenness, a lot of accuracy. You're supposed to know that questions on area approximation can appear in any of the papers. And wherever they appear, these questions are supposed to be scored 100%. You're not supposed to miss them. Therefore, one thing that you're supposed to know is that use trapezium rule or trapezoidal rule with 10 strips. Look at that instruction. 10 strips to estimate the area bounded by the curve y equals to 6 plus 3x minus 2x squared, line x equals to 3.5 and x equals to negative 1.5. One thing you're supposed to know is that the area by trapezium rule is given by half height into the first height plus the last height, then plus 2 multiplied by all the other heights now in between, up to the height just before the last one, up to the height just before the last one. So that's how we get the area using the trapezium rule. The formula first. Now, how do we substitute in this formula? We are supposed to substitute some known heights of this particular curve. So we are supposed to get, we are supposed to examine this interval. Then we compare it with the strips that we are given to use. From negative 1.5 all the way to 3.5, we have 5 intervals. So if we use 1 unit from one height to the other, we are only going to have 5. So for us to ensure that we have 10 strips, then we have to use intervals of 0.5 instead of 1 unit. We use 0.5. That's why in the values of x, then corresponding values of y, we are supposed to ensure this. Let me show you. We are supposed to ensure that we use intervals of half, because if we use intervals of full units, we will have only 5 strips, but we are needed to have 10 strips. That's what I wanted you to get serious. From negative 1 all the way to 3.5. From negative 1.5 to 3.5, using 1 unit interval, we shall have 5 strips. So for us to come up with 10 strips, according to the instructions, we should use intervals. We should shorten the intervals. So from negative 1.5, we're supposed to go to negative 1, then negative 0.5, then 0, 0.5, then 1, 1.5, then 2, 2.5, then 3, 3.5 finally. So these are now 10 strips because we have used the right intervals. If you use intervals of a whole unit, be assured that the strips will not be 10. Therefore, now we substitute the values of x for us to know the corresponding values of y. We have the function here, which is going to give us the values of y. So 6 plus 3, you open brackets 1, negative 1.5, minus 2, you open brackets, negative 1.5 squared. That gives us negative 3. Then we use negative 1. 6 plus 3 into negative 1. You use your calculator very well. Minus 2, you open brackets, negative 1 squared. And that will give us exactly 1. Then at 0.5, we use 6 plus 3 into negative 0.5 minus 2 into negative 0.5 squared. So we get 4 at that particular point. At 0, 6 plus 3 into 0, negative 2 into 0 squared, we just get the 6. Everything else becomes 0. So the value of y there is 6. Then at 0.5, you substitute. At 0.5, you substitute, and you shall get 7. Then at 1, you substitute, and you shall get 6. At 1.5, at 1 we get 7. Sorry for that. At 1, we shall get 7, yeah? And there is already a typed 7 here. At 1, we get 7 again. 6 plus 3, then minus 2. Yeah, it becomes 7. Very true. So at 1, we also get 7, just like at half. Then at 1.5, we get 6. At positive 2, we get 4. At 2.5, we get 1. At 2.5, we get 1. At positive 3, we get negative 3. At positive 3.5, we get negative 8. So you are supposed to use the function very well. And remember, you have a calculator, so you don't have to struggle to substitute. You just type in the calculator once, the whole function. 6 plus 3, you open brackets, minus 2, you open brackets again. You put the value of x, you close brackets, squared. You close brackets, squared. Very simple. So you come up with all the values of y. Now, we are supposed to know something here. We are finding area. Therefore, these values of y, which are having negatives, the negatives are supposed to be ignored. The reason why we ignore negatives and use the absolute values is because the value of y here is just to tell us that this value of y is on the lower side of the x-axis. But we are interested in the size. So it is, for example, the first value of height is a 3. The negative is just to tell us where it is found on the lower side of x-axis. That's why when finding area, we just ignore, so that we just get the amount of area. We don't focus on the sign now. We focus on the size. When we are having negative 8 as the last quantity, it means these are just 8 units on the lower side of x-axis. And that's why we are supposed to ignore the sign. We just want the 8 now. So at this level, we are interested in the size. We ignore the sign in substituting in the formula. So area shall be half multiplied by, what is the height? From one point to the other, we are using 0.5, ladies and gentlemen. Then now we open the bigger brackets. The first height is 3 and the last one is 8. So I have ignored all the signs. I'm picking absolute values. Then 2 multiplied by. Now the other heights in between those two. The heights now in between the first and the last. 1, 4, 6, 7, 7, 6 again, 4, 1, and positive 3. We take positive 3. We ignore the sign completely. We just ignore the sign completely. So this becomes 0.25 or a quarter into 11 plus. So let me add. So that I multiply by 2. 1 plus 4 plus 6 plus 2 7s plus 6 and 4 plus 1 and 3. Sorry. Okay. 5, 11 plus 14, 25 plus 10, 35 plus 4, 39. I hope that is well calculated. So I'll be having a quarter into 11 plus 78. You know, 11 plus 78 is 89. So we multiply this by a quarter. And I'm getting 22 and a quarter square units. Remember, the answer can be slightly different when you use a different number of stripes. When you use 5 strips, for example, the answer will be less accurate. The more the strips, the more accurate you are. Something that you're supposed to know. The more the strips, the more accurate you are. I thought that's important for people. So in case the part of using the number of strips is optional, it is advisable. It is advisable for you to use as many as possible. As many as possible. Okay. Number 13. Again, an interesting question. I'm hoping that you guys are getting something. Thank you, Mr. Otieno from Garissa. The trapezium rule. Aha. Thank you, Oliver from Collins. Thank you, Oliver. Thank you, Oliver. Marimo Mtamixed. Thank you. What about registration? Kindly reach out through our number. But I've said the registration is a very reasonable amount. Very reasonable. We don't scare away any clients. 04153366. Please reach out. Don't shy off. Reach out. Approach your guardian. Cheney Girls, thank you. Alliance, thank you so much. Thank you, very important. All right. Mr. Otieno, thank you. Thank you, thank you, thank you. Okay. Number 13. Let's again focus on this one. Let's pay attention on this one. Simplify fully the result of the following expression. 6a plus 9 into a minus 5 divided by a squared minus 2a minus 15, then plus 2a power 3 plus a squared divided by 2a squared plus 7a plus 3. To work out this, we are first going to deal with the left-hand side. We finish up everything. Then the right hand side. Let me begin with the left hand side. From the left, and on the numerator, left numerator, we're going to talk about, remember 6a plus 9 is not fully simplified because there is a 3 in there. When you factor out 3, you remain with 2a plus 3 that way. Then we are having a minus 5. So the numerator is simplified at that point. We have simplified the numerator on our right. Yeah, on our right hand side. If that is simplified, then we can check the denominator then. The denominator is quadratic, a quadratic expression. So if it's a quadratic expression, confirm if you're understanding something, please. If it's a quadratic expression, we are supposed to get a product of A times C. We need a product equal to negative 15 and a sum which is equal to the value at B, which is negative 2. So these two terms are negative 5 and positive 3. When multiplied, they give us negative 15, and when added, they give us a negative 2. Therefore, now we replace negative 2 with negative 5 and positive 3. So we rewrite the denominator as a squared minus 5a plus 3a, then minus 15. And we factorize now. From the first two, ladies and gentlemen, there is a which is common. So we remain with a minus 5 plus 3 is common in the last two. So a minus 5. Inside the brackets, we have a minus 5. Outside the brackets, we have a plus 3. So now, this right hand side now can be compiled now. Let me now bring everything together and say, we are having 3, 2a plus 3, a minus 5, a plus 3. So with minus 5 is appearing here and also here. Therefore, 3 into 2a plus 3 out of a plus 3. So we have now simplified the right hand side fully. The right hand side is simplified. Let's check the left hand side and what can be simplified. So on the left now, we pack this answer first. Just pack it there. We deal with the right hand side now. So on the right hand side, you can see the numerator first. The numerator on the right hand side is a squared. When we factorize a squared, we shall remain with 2a plus 1. What about the denominator? The denominator is quadratic. So, being quadratic, those who are saying hi teacher, let them remember that our number is on the board and they can reach out for these papers and more programs. On the denominator now, which is quadratic in nature, we need a product, two factors, whose product is 2 times 3, that is 6, and sum equals to 7. So this is going to be 6 and 1 multiplied to give us 6, added to give us 7. So 7 can be split into 6 and 1 now, whereby the denominator here, let me clear it up. Yeah, the denominator here can now be written as 2a squared plus 6a plus a, then plus 3. And we from the first two, I'm factorizing 2a so that I remain with a plus 3. Then in the last two, I'm factorizing only 1 to remain with a plus 3. So I'm having inside the brackets a plus 3, outside the brackets 2a plus 1. 2a plus 1, that way. Yeah, 2a plus 1. So now we can combine the numerator and the denominator of the right hand side. This question is involving. This one is quite involving, and a student is supposed to be very careful. So on the right hand side now, we are having a numerator which is a squared 2a plus 1 out of a denominator which is here a plus 3 into 2a plus 1, whereby 2a plus 1 is appearing on both the numerator and the denominator. So this shall be a squared out of a plus 3. This is now the solution for the right hand side, and the solution for the left hand side is here. The solution for the left hand side is now here. So now we are supposed to combine the two. We are now supposed to combine the two. If you are following carefully, you will be able to understand what we are doing. Please be carefully following. Remember to subscribe. Remember to share. Remember to invite a friend to our broadcast. Remember to always come back again and again. I must make this one clear that in shifting grades, there are more than 2,000 lessons that you've not even exhausted. So even after this live, even as you wait for tomorrow's live, you should be in a position to take your time and go through our platform and learn a lot. Just be ahead of people. Be ahead of time, and that's how people grow. Okay, let's look at this. Looking at this now, we are having 3, 2a plus 3 out of a plus 3, then plus a squared out of a plus 3. So you see, they have shared the denominator now. They have, the two sides have shared denominator. Thank you, William from Nakuru. Thank you from Siaya. Shadi from Siaya, thank you. So now the LCM is common. And if it is common now, I'm going to use the space for this number 14. Allow me use the space for number 14. Then we'll be seeing what to do after that. So the LCM now becomes a plus 3 because the denominators are just the same. So LCM divided by the first denominator, we get 1. So that we have 3, which becomes now 6a plus 9. Then plus LCM divided by the second denominator, we get 1. So this becomes a squared. That way, a squared. So at that point now, we can see the numerator now that we are getting can further be factorized. It can further be factorized. And if it can further be factorized, by first writing it as a squared plus 6a plus 9. So we need to split 6 into 3 and 3. A squared plus 3a plus 3a instead of 6 now, plus 9. So from the first two, we factor out a. We remain with a plus 3. And in the last two here, we factor out 3 to remain with a plus 3. So from the brackets, we are having a plus 3, and outside the brackets, a plus 3. But remember, we were having this denominator here over A plus 3. So A plus 3 cancels this way, and our answer now becomes A plus 3. This is now our final answer, the very final answer. Nairobi School, thank you so much. Thank you, Nairobi School. Anytime from 7 p.m., we usually begin our classes. Anytime from 7, we usually begin our classes. But we are concluding now. We are concluding. This is a very interesting question. Look at the space it has carried. Just look at the space. Look at the space it has consumed. So you should know questions. Okay, number 14. A very interesting question once again. Determine the values of P for which the matrix 2P plus, 2P to negative 7P, P minus 4 is a singular matrix. As a student who has covered from the work, you're supposed to understand what a singular matrix is. This is a singular matrix is a matrix which has no inverse. And if a matrix has no inverse, then this matrix has a determinant which is equal to 0. If it has a determinant that is equal to 0, we can get the value of P. So the value of P shall be, we express determinant first. Product of the elements in the leading diagonal or the main diagonal, 2P multiplied by P minus 4 minus product of the elements in the other diagonal. So negative 7P times 2. This one is the determinant, and it's supposed to be equal to 0 for a singular matrix. Determinant equals to 0 for a singular matrix. All right. If that is so, then we say 2P squared minus 8P, then negative 7 by 4 by 2 becomes 14. So minus negative 14 becomes positive 14P. This is equal to 0. At this point now we can say 2P squared plus 6P, because of negative 8 plus 14 equals to 0. We can solve this one now and say, first we need to factorize 2P to remain with P plus 3 equals to 0. So 2P equals to 0, and hence P equals to 0. Or P plus 3 equals to 0. So P is implied to be having a negative 3. P equals to negative 3. So that's how number 14 was supposed to be done. So effectively, number 14, a very simple question. Let's look at a serious question again in number 15. Form the three inequalities, the three linear inequalities for L1, L2, L3 that satisfy the region R, the region marked R. So we have a region R here for these particular inequalities. And we are supposed to form the inequalities which satisfy this region. So the inequalities have been represented graphically. So it's upon us now to extract them from the plotted lines. This one is usually a very simple work. Very simple work. And students should be able to maneuver. Students should be able to understand what is happening. So let me show you how to go about this one. We shall do each line slowly by slowly. Line 1. Look at line 1. Look at line 1. So we first come up with the equation for the line. We first come up with the equation for the line, L1. So the equation for the line requires us to have some coordinates. Like this one is a coordinate. You pick the fixed coordinates which will not disturb you in coming up with the gradient or trying to interpret what the values are. So you pick from the axis. mostly. For example, the first coordinate there is 0, 2. Let me bring it here. Yeah, 0, 2. Then for line 1, along the x-axis, we are having 3, 0. We are having 3, 0. 3, 0, that way. So we find gradient first. The gradient means change in y. So 0 minus 2. Change in x, 3 minus 0. So this is negative 2/3. We have a gradient of 2/3. Now I want to show you, because the line is plotted, you are not supposed to calculate the line. You are not supposed to struggle. Remember the general equation of a straight line, y equals to mx plus c. In this general expression of a straight line, the value before x is usually the gradient, and the constant here is usually the y-intercept. So for this particular L1, we have all those constants. So we can write our equation direct and say L1 shall be y equals to the gradient negative 2 out of 3 x plus the y-intercept for line 1, which is a 2. So we have our equation without struggling, because we know according to a straight line, just before x, we shall have the gradient, and the constant to be added is the y-intercept. And we can read the y-intercept right from the graph. Y-intercept is the point where the line cuts the y-axis. So from the graph, we can read that one so comfortably. Positive 2. It's almost ending. We're in number 15, and we are going up to 16. So now from this, we can do away with the fraction and talk about 3y equals to negative 2x plus 6. That is now the equation. Now that we have the equation of the straight line, let's talk about the inequality symbol to be used now. Because we were not looking for an equation, we are looking for inequality. So which inequality symbol will suit this one? We come to the required side, we come to the required region, the region which has been satisfied. And in this region now, we are supposed to identify any coordinate. Let me identify a coordinate in this region. A coordinate x, for example. This is coordinate negative 2, 2. I've identified any coordinate, and we will use it for all the lines. Negative 2, 2. Then now, this coordinate, we shall replace it in the line that we are having, so that we may see the left-hand side and the right-hand side. How do they relate? So 3y, we write 3. According to the coordinate, y is 2. Then that's our left-hand side. On the right, we start with negative 2. Then the value of x, negative 2, plus 6. So this shall be 6. But on the right, we are having 10 because of 4 plus 6, which is a 10. Now you ask yourself, what is the relation between the left-hand side and the right-hand side? And the fact is that 6 is less than 10. If 6 is less than 10, then the inequality to be used in the above equation should be that of less than. Therefore, we say 3y is less than negative 2x plus 6. This is the first inequality. Remember, L1 is dotted. It is not a complete line. So if it is not a complete line, we use strictly less than. In case it was complete, we would have said or equal to. In case it was complete, a complete line, we would have said or equal to. Let's check the second line, L2. Let's check L2. I hope you are seriously following. We can now check L2. Thank you, thank you. Let's check L2. As we check L2, those who are joining us late, let them be informed of our program here, whereby you just inquire from the number here, 070415 3366, a very serious program whereby we are bringing on board very serious facilitators in the sciences, mathematics, and the languages to ensure that candidates are well equipped. Form 3s and Form 2s are also supposed to join, so that in advance they start knowing what to expect. As you revise the right thing and in the right way. You reach out through a number 0704 15 3366. Just reach out so that you may register for our program, talk to your parent, talk to your guardian, and get enrolled. Okay, line 2. I want us to solve together. Line 2. We identify coordinates again. I'm getting first coordinate here is 5, 0 according to the y-intercept. 0, 5. That is one of the coordinates. Then on the x-axis for line 2, negative 4, 0. Let's look at this now. Negative 4, 0. Let's find gradient. Change in y. 0 minus 5 out of, change in x, negative 4 minus 0. So I'm getting negative 5 out of negative 4, whereby the negatives will cancel to get 5 over 4. 5 out of 4. Thank you, thank you. St. Joseph's Kibwezi, thank you so much. Garissa High, thank you so much. Okay, now with this particular gradient now, we need to go direct to the equation now. Let's go direct to the equation. Reason because we have the gradient and we are having the y-intercept for this line. So there is no need to calculate equation. We write y equals to the gradient 5 over 4x plus the y-intercept, which is a 5. So for line 2, the line is cutting the y-intercept. The line is cutting the y-axis at 5. So that's our y-intercept. So we have written our equation. Now we can do away with the fraction by multiplying by 4 through. So 4y equals to 5x plus 20. We are now not having fractions. Then we can use our coordinate. Our coordinate, which is in the required side, is negative 2, 2. Coordinate negative 2, 2. This coordinate now should be substituted in the equation so that we know the relation between the right hand side and the left hand side. On the left, we shall have 4 and 2 because y is 2. Then on the right, we have 5, negative 2 plus 20. So this is 8. Then we are having negative 10 plus 20, which is positive 10. Negative 10 plus 20, we get 10. What is the relation between 8 and 10? The relationship between 8 and 10 is that 8 is less. Therefore, the symbol is less. So 4y less than 5x plus 20. But something else that you're supposed to be very careful with, when you look at the graph very carefully, you discover that line 2 is a complete line. It is a complete line. A complete line, meaning that we shall have or equal to, less than or equal to, because of the complete nature of the line, or equal to. Then finally, we have line 3 now. Line 3 is passing through the value of y, which is 2. Therefore, the line itself is y equals to negative 2. Yeah, it is on the lower side of x-axis. Y equals to negative 2 now. So we ask ourselves, the required side, is it having values of y which are greater than 2, greater than negative 2, or less than negative 2? And it is a complete line. So it should be either greater than or equal to, or less than or equal to. Therefore, We pick a point on the required side. Our point is negative 2, 2. The value of y is 2, 2. And on the right, we have a negative 2. The relationship is that 2 is greater than negative 2. So if 2 is greater than negative 2, then the inequality symbol to be used is greater than negative 2. But now we introduce or equal to. We are introducing or equal to because of one reason. Or equal to because of one reason. The line is complete. So this is the third linear inequality. The first one was here, and this was the second one. So we have done the three of them. Remember to use this knowledge. You did it in Form 2, and you did so that you may apply, not to decorate your books. You did so that you may apply the concept. We are finishing at number 16, ladies and gentlemen. And we are told that John's strides are 48 centimeters long, while John's are 54 centimeters long. If they take exact number of strides to cross the road, find the number of strides Johan takes. The first thing that we are supposed to find is the size or the width of the road that they are crossing. We should look at this particular number, which can be divided by both 48 and 54 without a remainder, because they are taking an exact number of times. Therefore, this particular multiple of both 48 and 54 is going to be the size of the road, or the width of the road that they are crossing. Therefore, we find the LCM of 48 and 45. LCM, so that you may know the road that they are crossing. 48 and 54. 48 and 54. And we are assuming that the time they are taking exact number of strides, they are going to finish crossing the road. So we start by 2, the least prime factor, 2, 24, 27. By 2 once again, 12, 27 cannot be divided. By 2, 6, 27. By 2 once again, 3, 27. By 3, this becomes 1 and this becomes 9. So by 3 once again, this remains to be 1, this becomes a 3. And by 3 now, we have 1, 1. Therefore, the LCM is 2 power 4, yeah, and 3 power 3. So what we get is the LCM. 2 power 4 is 16, and 3 power 3 is 27. So I'm getting 432 centimeters. This one, as the LCM, is now going to be the width of the road. This is the width of the road that they are crossing. If that's the width of the road they are crossing, then exact number that will be made, number of strides by Johan, we take 432 divide by 1 stride is 54 centimeters. So how many strides is she going to make? We divide by 54. We are going to have 432 over 54. We are going to get 8 strides. 8 strides. So that's all in section 1. Remember, you can support our programs by using the tail number which is attached here. 497742. Your support will go a long way. I know most of you are students and you don't have a lot of money, but you can look at the work that we are doing. Let's know that we can support with whatever we have. Somebody can choose just to pay the Wi-Fi for this month. Very cheap, 4,000. Our Wi-Fi is sorted, or whatever you have. 497742. See you in the next live presentation. All the best to everybody who is preparing for examinations. Thank you so much.